Hello folks, we are once again back with this exercise 7.5. This is a exercise of partial fractions. We have already finished till the problem number 11. Now we are into the problem number 12. Let me check what the problem says. The problem says that it is I is an integral of x cube plus x plus 1. Let me check. X cube plus x plus 1 over x square minus 1 dx. I had told you in the previous problem also, that is I should be, if I am precise, it's at problem number 6, where I had told you that if at all the numerator and denominator has got equal powers, or if the numerator has got a higher power than the denominator, then we are going to go in for a division, and it's division which is going to help us. So this is that kind of a problem where the numerator's power exponent is 3 and the denominator's exponent is 2. The highest exponent, the degree actually. The degree of the numerator is 3 and the degree of the denominator is 2. Since the degree of the numerator is higher than the degree of the denominator, we will resort for division. So it's by dividing that we will be doing this problem. So right away let's start with division. So let's divide this. Let's divide x cube plus x plus 1 with x square minus 1. It's very clear that x has to be the first quotient. So it's going to be x cube minus x. So as we subtract, we have this getting cancelled, x plus x, 2x plus 1. So it's very clear to us that I now becomes, because we know that dividend equal to divisor into quotient plus remainder. So let's use that. This is our dividend, which is x cube plus x plus 1. We are replacing by divisor into quotient plus remainder. So it is going to be x times x square minus 1 plus 2x plus 1 over x square minus 1. What have we done? We have used the fact that dividend equal to divisor into quotient plus remainder. Now because this is common to both these fractions, let's split it up. It will become x times x squared minus 1 over x squared minus 1, the first part, and the second part is going to be integral of 2x plus 1 over x squared minus 1 dx. Now this will cancel each other, so we will get the first part as x dx. Let's split this also actually, 2x and 1. Let's split it into two integrals. So here it will become 2x over x square minus 1 dx plus 1 over x squared minus 1 dx. Now this is a very rosy kind of affair over here, because this integral x dx is very easy to integrate, and you have the denominator with x squared minus 1 and the numerator is 2x. Numerator is incidentally the derivative of the denominator. So if you have the numerator as a derivative of the denominator, you can use the substitution u as x squared minus 1 and the numerator will become du, and in turn it will become log. So it will become log of x squared minus 1. So if your numerator is by any chance the derivative of the denominator, this is going to be log, you are going to get the integral as log. So that way even this is sorted out, and this is of the type integral of x squared minus a squared. So that way all your problems are sorted. Only thing I will have to check once again, because sometimes I will just reverse minus and plus and then it will become the big affair. Yeah, this is x squared minus a squared. So x squared minus a squared as a 1 over x squared minus a squared dx. We had done it as a standard integral. So that value we will, that integral we will substitute and we'll get the answer. So let's see now what is this. X dx, it is x squared over 2. This, as I said, log modulus x squared minus 1. Now a small advice here for those for whom it has not become clear, you can just substitute u as x squared minus 1. So du will become 2x dx. That way the integral will become du over u, and that's how log it is coming as log. And this is a standard integral. Let me write that integral of dx over x squared minus a squared, which is always 1 over 2a log x minus a over x plus a plus a. Yes, so therefore here it is 1 over 2a for us is 1. So 1 over 2a means it's 1 over Let's write it, isn't it? We have written the integral. So it's 1 over 2 log modulus x minus a. So x minus 1 over x plus 1 plus c. It's only this much. Okay. By tracing it up directly, this is how your work is. That's it. Yeah. So that's all for this problem. Maybe with the next problem, I will just check. Yeah, with the next problem we can meet in the next video, because that's a little laborious problem. It will not fit here. So with the next problem, let's meet in the next video. So that's all for this video.